If you know me, you know I love language and I know it's critical for reliability to be effective. So what is the formal definition of reliability? It's the probability an item will perform its intended function under stated conditions for either a specified interval or over its useful life. There are three key terms in that statement. Actually, they're more than key. They're essential. You cannot have a valid reliability statement without them. They are intended function, stated conditions, and specified interval. If all three of those are not clearly defined, the associated reliability promise is completely invalid. Let's take an example of a customer and a manufacturer interaction. In this case, we have a customer who regularly purchases large quantities of utensils and is looking for a new supplier. Okay, in this situation, we have a customer who calls up a utensil manufacturer and wants to purchase utensils, knives, forks, and spoons. And he purchases them in large quantities. So he asks this manufacturer, how reliable are your forks? And the manufacturer says they are 99.99% reliable. And the customer says, that's fantastic. We'll take a full order. And they do. And then the customer calls back to manufacturer within about 2 weeks and says, these forks are failing all over the place. And the manufacturer is confused. He says, how is that possible? And so they start to talk about what's going on. And the customer reveals that they use the forks for prying open cans, that they actually are a company that supplies to expeditions that go on adventures different places around the world. And the forks that they typically carry are metal. And what they were looking for is a new lightweight solution. And that's why they contacted this manufacturer and wanted to use plastic forks. Well, it was obviously not discussed how the intended function was applied. So the customer agrees that they won't use the forks for prying things open. They will save that for other tools they have and use them for the intended function of just simply eating food. Okay, now the customer calls back 2 months later and the forks are breaking again. So they begin discussing a situation with the manufacturer. And they're not using them to pry anything open. They're using them as intended for only eating food. So as they continue to discuss what's going on, they discover that the problem is the expedition has continued to where now it's winter and the temperatures are extremely low, down to -20 degrees, and the plastic forks are breaking. And the manufacturer says, yeah, we don't promise a reliability of 99.99% with plastic forks at -20 degrees. They're going to get brittle and break. Well, this wasn't discussed. And when the customer decided to purchase the forks, they had made the assumption they could be used in all the same ways as the other forks they had used before. So time goes on again, and then a year later, they call the manufacturer again and say, these things are breaking all over the place. And the manufacturer states, you're still using these things? That 99.99% was promised for the interval we intended plastic forks to be used, which are pretty much a one-time use or a couple times. You can wash them and use them a few times, but a year, the amount of UV exposure alone is going to break down the plastic dramatically. So you can see how making a reliability statement and not being clear on intended function, stated conditions, or specified interval ensures that you're going to have a lot of confusion and the reliability statement made has no meaning. So probability and statistics underpin reliability engineering, but conditions and timeline underpin how we use our statistics. Do customers rank us based on statistics, or do they rank us based on their experience with our product? They rank us on their experience. We have to look beyond our intended use cases as well. Reliability is a fulfilled promise, but it's their interpretation of that promise, not ours. The promise may be as simple as 30 minutes of dependability, like the one-time use plastic fork. The promise may be impeccable performance to the end of time, like a fork from a wedding gift-worthy silver flatware set. We expect that silver fork to perform perfectly forever. It's intended to be handed down for generations. Quite simply, the warranty should be transferable to the archaeologist who digs it up in 2,000 years and chooses to use it for lunch when no one is looking. These expectations don't necessarily come from your product specifications. Customers don't read manuals. So it's unlikely the customers have even read the product specifications. They're going to use the product in ways far beyond what is spec'd. Even if the spec is on a big red sticker by the handle, do not get wet. Clean after each use. Keep away from hot surfaces. Yes, technically the product manufacturer isn't responsible for failures at or beyond the edges of specified use, but unfortunately there is no consumer product court where the manufacturer gets to make their case. Instead, there is a virtual witch trial that takes place in online forums and e-commerce reviews. An effective reliability design process follows the product through its entire product development cycle and uses closed-loop feedback to ensure we are consistent in being effective and efficient. There is also a great deal to learn from what happens in the field, even if it was a great product launch. We will find valuable information that tells us how to improve our design process as well as the next generation of products. So define your product's reliability completely. Welcome to the Defining Reliability worksheet. So as you just learned about the definition of reliability, which is the probability an item will perform its intended function under stated conditions for either a specified interval or over its useful life, we saw how critical it was to have very specific definitions for those three key elements: probability, function, conditions, and specified interval. So can you list those out for your product? You should do it also for other products, not just the one we're doing in the project. It's really a great exercise. And then write that full statement out. So we also want to see if we can begin to quantitatively identify how we've measured this in the past. How have you been measuring reliability in your organization? Is it percentage reliability, like you're looking for a 99.9% reliability? Is it mean time between failure? Is it failure rate? And where is this coming from? Are you getting goals from somewhere, from standards or handbooks? Are you measuring from field data or just measuring from in-house test? So this is really great information for you to capture now.